Hello, this is Ms. Cliffner with your video lesson for today. It is about reviewing calculating measures of center and measures of variation. And we're getting ready to put all of the information together and figure out which measures of center and variation are best to use. Okay, so I'll start off by showing you the warm-up. Here's a list of prices for 8 different printers, and I'm asking you to find all the measures of center, including if there's outliers, as well as measures of variation. Remember, measures of center are how you find an average, and measures of variation describe the spread of the data. Okay, so here is, these are all the numbers put in order, which you don't have to do for the mean, right? But it kind of makes your life a little bit easier. So there's the mean. I add up all the numbers and I divide by 8 because there's 8 printers. So you get $120. The median is when you work your way to the center. I'm going to use a yellow. No, I'm going to use a red highlighter. Okay. So when I work my way to the center, there are 2 numbers in the middle. And if there's 2 numbers in the middle, that is the middle number. And so the median is also 120. And the mode is the one that shows up the most, which there are 3, right? Because each of the 90, the 120, and 140 are both listed twice. And then the outliers, it makes sense to actually address the outliers when we get over to the IQR because you need that number for the formula. So just a reminder, the lower boundary was Q1 minus 1.5 times the IQR, and the upper boundary is going to be Q3 plus 1. Range, super easy, the biggest number minus the smallest number. There it is, the IQR. Okay, so now here's where I'm going to go back to the numbers that I have in order, and I'm going to go ahead and cross off the 120 and the 120. And I'm going to draw a line down the middle because I have to use the 120s, even though they were the 2 middle numbers. One of them belongs in the lower half and the other one belongs in the upper half of the data. So I'm going to use a highlighter in a different color, and I'm going to cross off from the outside and find my way to the middle of the 2 numbers. This is the Q1, was right in between 90 and 110. It's 100. So the Q1 equals 100, and then the Q3, I work my way to the middle, which is 140. And so Q3 equals 140. So when I do the IQR, it's Q3 minus Q1, and I get a range of the middle half of the data is 40. And then the MAD, so a lot of times what you can do is use a number line and figure out how far each of these is from the mean, right? So over here, the mean is 120. So 90 is 30 away if you want to do a dot line, or you can just write the numbers. Like I could put the 30 up here, the 30 and the 30. So let me show you how we did that before. You can use the dot plot, or you can write the numbers underneath. So this is what I'm going to use to find the MAD. I'm going to write the distance from the average. So 90 is 30 away. This other 90 is 30 away. This is 10 away, 0, 0, 20, 20, and 30 away. And you're going to add all of those numbers together, and you're going to divide by the number of numbers. So when you divide by 8, you get 17.5. So the MAD is 17.5. Now I'm going to find out, were there any outliers? So I take the Q1 over here, 100, minus 1.5 times the IQR, which is 40. So I get 100 minus 60 equals. There are no numbers that are less than 140 on that list, so there's nothing on the smaller side. And now I look at the Q3, which is 140. Also the 1.5 times 40, which we already know is 60 because we just calculated it once. 140 plus 60 is 200. And there are no numbers in the list greater than 200, so there are no outliers. Okay, so now to find the best measure of center and the best measure of variation, there's some rules that we use. One of them is when there's outliers, the median is better and the interquartile range is better. That's because, remember, outliers affect the mean. So if there are no outliers, you're going to use the mean and the MAD. Okay, so that has to do with outliers, but then we also choose the best measure of center based on variation based on the shape. So I came up with this rhyme to help you remember. If it's symmetric, please don't wreck it. Use the mean and the MAD. Don't make your teacher sad. If it's skew, it's up to you. Drive the median in your car and you use the IQR. So hopefully that helps you remember. And now we're going to check and see if you kind of understand how the shape decides which measure to use. Okay, so we're going to do a thumbs up or thumbs down. You can pause the video if you want. Look at the first graph and tell me the shape, right? So if you draw a line like this, you can see that it's skewed and the tail's on the left, so it's skewed left. And if it's skew, it's up to you. Drive the median in your car and you use the IQR. Okay. And then this histogram, right? I could outline a histogram the same way I do dot plots. And this time it's skewed right. The tail is on the right. And I would use the median and the IQR. And if it's symmetric, please don't wreck it. Use the mean and the MAD. So that's what I would use to find the average. Not saying that you can't use the median, but in general, if it's symmetric, you can go ahead and use the mean. Add up all the numbers and divide by how many. Okay, so now we're going to look at a real life application where we're going to be comparing how two pitchers are doing, right, in 10 games. And we're going to try to figure out which measure we can use to distinguish the data and what can we conclude. Okay, so here we go. First, we're going to look at Mendoza, and we're going to try to calculate the mean, the median, and the MAD for the number of runs that were scored against him. Right, so here's all of his numbers, right? And when we find the mean, we add up all the numbers and divide by how many, and we get 3.5. Okay, now for the median, we want to put the numbers in order from least to greatest. There they are. And then we start crossing them off from left to right. And we get two numbers in the middle, which are 4. That means the median is 4. Okay, and then for the MAD, another, one of the ways I can do this is underneath, I could figure out how far each number is from this mean. So I can use a dot plot, or I can just do this. The 0 is 3.5 away. The other 0, 3.5, right? These are all 3.5 away. The 2 is 1.5. The 2 4s are 0 and 0. The 5 is 1.5 away. I can do the math. Oops, I didn't erase that 2, did I? Okay, so 4 is, oops, what am I doing? Why did I think the average was 4? It's not. This should be 0.5, and this should be 0.5. Okay, now I'm on to how far is 5 away from 3.5. 1.5, not very fun to do with decimal numbers. And then 6 would be 2.5, 2.5, and then 8 would be 4.5. So we take all of those distances from the average, and then I divide by 10. Okay, so there's all my numbers. That's what it looks like in a dot plot. When you add up those, you get 24, and when you divide by 10, you get 2.4. So the mean for Mendoza is 2.4. Now remember what we learned last week was the lower the MAD, the more consistent. So let's see how they're doing with runs scored against them. 2.5 for Mendoza. Okay, now we're going to compare the data for Rodriguez. So here are all the runs that he scored. And we take all the numbers and we add them up and divide by 10. And we get 3.5 for the mean, same mean, okay? So remember, if the mean is the same, we're looking for something else to help distinguish the two players. And then for the median, I've got the numbers lined up and I work my way to the middle. Okay, better get my battery plugged in. Oops. 1, 2, 3, 4. There we go. There's two numbers in the middle. Hey, wait, the median is the same too. Okay, so got my computer plugged in. All right, so the median is also 4. Again, not super helpful. So hopefully the MAD will be different, and then we can at least come up with some conclusion about these guys. Oh, and I can see my video is not showing. That's okay. Let's just move that over. Okay, so for the MAD, I can list all the distances from 3.5, 0 to 3.5, right? This is 3.5, 1.5, 1.5, 0.5. 4 is also 0.5, another 0.5. So I've got 1, 2, 3, 4, 1, 2, 3, one more 0.5. Then I've got a 1.5, a 1.5, and a 2.5. Once I have all of those numbers that are the distance, so we're now trying to find the average distance from the average. And I add all those numbers together and divide by 10. And this time I get 1.4. Okay, so there we finally have something that's different about them. So the idea, here's all of our data, right? So it turns out that the mean was the same. The median was the same. But now we've got the MAD is 2.4 of Mendoza and 1.4 for Rodriguez. Right? So here's what we can finally come up with some kind of a conclusion here. And because the measures of center, right, the mean and the median are the same, they don't really help us distinguish anything, but the MAD shows that Rodriguez has less variation, right? The smaller the number, sorry, over here, the smaller the MAD, the more consistent. Okay, so all right, so now I just want to look at what happens if Mendoza allows 4 runs in the next game. How would we expect the mean absolute deviation to change? So let's just remind you that the mean for Mendoza is 3.5, his MAD is 2.4. Okay, so if he allows 4 runs in the next game, I'm hoping that you see that the MAD will decrease. MAD will decrease, but the distance, so we're just thinking about the average distance, right? The distance from new value to mean of 3.5 is less, is less than the current MAD. Right, because he allowed 4 runs and the distance from 4 to 3.5 is 0.5. So it might go down a little bit, but he's still less consistent. All right, so here's a picture of what the homework looks like. You are choosing the best measure of center. You're supposed to describe the shape of the distribution, choose the most appropriate measure to describe the center and the variation. So here's kind of how I set it up. All you have to do is circle from here the measure of center, circle the variation. You can remember the rhyme that I gave you, and then you have to do calculating 1 measure of center and 1 measure of variation. All right, good luck.